Good afternoon and welcome to all. Today in the methodology we are going to discuss about the other types of sterilizers. In the last session we have discussed about autoclave, and in the previous sessions we have discussed incubators, hot air ovens, etc. So introduction. In today's world, the need for the infection control has never been greater. The patients and the healthcare professionals have become more concerned about the transmission of pathogenic organisms than ever before. Controlling microbial contamination through sterilization has long been considered the most essential component of an infection control program. The result of the proper instrument sterilization is the protection of the patient and the healthcare professional from various infectious diseases. The focus on the infection control has sharpened. Since infections increase the severity of illness, that we already know, and the complicated recovery and the prolonged inpatient stays, they raise the cost of care. So there will be high cost for the hospital stay, etc. The ever-growing expense of healthcare has focused providers' attention on reducing the cost. So we are focusing how to reduce the cost. Often this means re-sterilizing and reusing expensive plastic items that might otherwise be discarded. So in the hospitals or in any healthcare institutions, instruments must be sterilized between usage, and there are several types of sterilization equipments. So we have already discussed autoclave. Here we are discussing about other types other than autoclave, but I am mentioning about autoclave here. Steam sterilizers. It is a type of instrument. Example is autoclaves. Then dry heat sterilizers are used. Heated chemical vapor sterilizers and gas sterilizers. These are the different types of other sterilizers used other than autoclave. Dry heat sterilizer. The dry heat sterilizers employ the higher temperature to destroy microorganisms. Example, hot air oven. We have already discussed. They are considered effective and safe for the metal instruments because the process does not dull instrument edges or rust or corrode the instruments. And there are two kinds of dry heat sterilizers. The traditional toaster oven style, that is slow, and it takes an hour to sterilize at 320 °F. Or the Cox rapid heat sterilizer, which is using a patented forced air and a baffle system technology to sterilize within 6 minutes at 375 Fahrenheit. CDC guidelines calls for a weekly monitoring the working of dry heat sterilizers by doing a weekly spot test. Usually this spot test we are doing in hot air ovens also. Next is about steam sterilizers. The steam sterilizers will allow you to sterilize a wide range of materials. Temperature, pressure and time are the main factors of this process. The higher the temperature, the greater the pressure and shorter the sterilization cycle, and the maximum temperature will rise to 273 Fahrenheit. Steam sterilization, however, may cause unprotected instruments to corrode and unprotected cutting edges to dull. Furthermore, excess water in the steam can provide a portal for microorganisms to penetrate wet instruments. Steam sterilizers or autoclaves are the most popular method of sterilization and are made and sold throughout the world in packages. There are several steam sterilizers sold in USA. and many more throughout the rest of the world. In the tabletop environment, chamber sizes ranges from 6-inch diameter to 14 inches deep to 15 inches diameter to 26 deep. So there are different types of steam sterilizers. Here also CDC guidelines calls for weekly monitoring the working of the steam sterilizers by doing a weekly spot test. Heated chemical vapor sterilizers. This type of sterilizers also offer relatively short cycle times. Metal instruments. This is another type of sterilizers, heated chemical vapor. In this, the metal instruments can be processed with minimal rust or corrosion, and also the cutting edges remain sharp. However, instruments must be dried completely before processing. That is important. The sterilizer requires a special solution, and a heat sensitive plastics may be destroyed. So we doesn't use a heat sensitive plastics in this method. In addition, the unit must be placed in a well ventilated area to diffuse the chemical odor. Here also CDC guidelines calls for weekly monitoring the working of chemical sterilizer by doing a weekly spot test. Chemical solutions. A liquid disinfectant such as glutaraldehyde are widely used in healthcare facilities. They have short, inexpensive disinfection cycle. However, glutaraldehyde cannot be used for all medical materials. Typical cycle times and concentrations only provide disinfectant, which can lead to the fail to kill the resistant microorganisms. So all types of organisms can't be killed using this chemical solution method. And the solutions are sometimes may be highly corrosive and toxic since they come in liquid form. They cannot be used with barrier packaging. The moment an instrument is removed from the liquid, its sterility is compromised. Immersion in a liquid sterilant is not recommended because the sterilization by liquid chemicals cannot be monitored biologically. So it can't be monitored biologically using spore strips. In addition, instruments disinfected by liquids must be handled aseptically, rinsed in sterile water and dried with a sterile towel. Furthermore, instruments immersed in liquid sterilants are not wrapped and therefore must be used immediately or stored in a sterile container. Otherwise, it may result in contamination. And this is the another type of sterilizers which are used in the dentistry. According to the American Dental Association Councils on Scientific Affairs and on Dental Practices, infection control recommendations for the dental office and dental laboratory, they presented in 1996 OSAP scientific form. It also showed that the type of sterilizer called glass bead sterilizer. This glass bead sterilizer have long been employed for instruments reused on same patients at the single appointment. However, they are not suitable for terminal sterilization of instruments prior to reuse on other patients. The reason they are not effective is that there isn't a way to test the temperature throughout the cycle. In fact, these glass bead sterilizers are not FDA approved, and any new machines must receive a pre-market approval, according to the Dr. Jani Fuller with the Infection Control Device branch of US Food and Drug Administration. So it is not much FDA. It is not FDA approved. And here also I am mentioning two types of sterilizers. We have already discussed steam sterilizer, dry heat sterilizer, etc. This is which are used in the primary care dentistry. That is vacuum benchtop sterilizer, a type B, and it is suitable for wrapped and unwrapped solid items, hollow items and porous loads, and as such is particularly valuable for sterilizing dental handpiece. And it is the standard for use in dental practice since the wrapped items can be readily transported, remain sterile up to the point of the use, and can be stored for use at a later date, minimizing the risk of cross-contamination. The type N benchtop sterilizer is an unwrapped instrument and utensil sterilizer suitable for solid devices that are not wrapped, provided that the proper irrigation and cleaning of lumens and internals of the handpiece has been achieved in combination with WD handpiece may also be proceed in type N sterilizer. Where remaining hollow items which are used in practice are single use, a type N sterilizer may be appropriate solution, although this type of technology is being increasingly overtaken by the vacuum type sterilizer. So, better than this method, vacuum type sterilizer can be used. Instruments processed in the type N sterilizer should ideally be used directly from the sterilizer, as transportation and storage of the sterilized items may pose a risk of recontamination. So, we should minimize those risk assessed activity to control and to minimize the risk of contamination. Thank you.